So in the last class, we were discussing what second order circuits, and any circuit that has energy storage elements, the response will consist of two parts. One is what? The forced or the steady state response. The other part is called as what? The natural or the transient response. Okay. So what is it? CR stands for what? The complete response. And the complete response will be equal to what? The forced response, also called as what? The steady state response, plus the natural response, also called as what? Transient response. So always the response will consist of two parts. And the natural response or the form of the natural response will depend on the poles of the system. So what will decide the natural response of any circuit? It is the poles of the circuit that will decide what the natural response, and what will decide the forced response or the steady state response. It is the type of source that is connected to the circuit that will decide the nature of the steady state or the forced response. Okay. For example, if the circuit is what? Driven by a DC source, it will reach DC steady state. And if the same circuit is driven by a sinusoidal source, then the circuit will reach what? Sinusoidal or AC steady state. Okay. Now for a first order circuit, you know, the two types of first order circuits we have are what? The RC circuit and also the RL circuit. Yes or no? These are the two first order circuits that we have, either the RC circuit or the RL circuit. Now the natural response of a first order circuit is always of the form A times e power minus t by tau. This is the form of the natural response of any first order circuit, be it the RC circuit or the RL circuit. The natural response is going to be of the form A times e power minus t by tau. And you know, every first order circuit is characterized by a time constant, and for RC circuit the tau is what? R equivalent into C equivalent, and for an RL circuit the tau is what? L equivalent by R equivalent. Just find the value of the time constant, use that time constant in this expression for the natural response. Well, this A times e power minus t by tau, it is only for a first order circuit. Again, let me make it clear that the first order circuit can be driven by any type of source. First order circuit can be driven by any type of source. That means, let's say you have an RC circuit driven by a DC source. Let us also say we have an RC circuit driven by an AC source. So as long as you have the RC circuit driven by any kind of source, the transient or the natural response is always going to be of the form A times e power minus t by tau. A times e power minus t by tau. Okay. So the point is what? The form of the natural response, it only depends on the nature of the circuit and not the nature of the source. And then when it comes to a second order circuit, what are the two types of second order circuits we have? In particular, we have the parallel RLC and the series RLC networks. Okay. So for a second order circuit, again the natural response, it can be one of three types. The natural response of any second order circuit, it can be one of three types. The first type of natural response is what? Over damped. The second type of natural response is what? Critically damped. And the third type of natural response of a second order circuit is what? Underdamped natural response. So these are the three types of natural responses that are possible for a second order circuit. Overdamped will consist of what? Two decaying exponentials. In fact, I can write overdamped case, the natural response is of the form a1 e power s1t plus a2 e power s2t. Let me write it properly. a2 e power s2t. What are these s1 and s2? They are the two poles of the second order circuit. How do you get the two poles of the second order circuit? You should form the characteristic equation, and the two roots of the characteristic equation are going to be the two poles of the second order circuit. And what about the critically damped case? Will it not be something like e power minus alpha t times a1t plus a2, e power minus alpha t times a1t plus a2. And what about the underdamped case? It will be what? Oscillatory in nature, but the amplitude of oscillation will continuously decay with time. So in fact, for underdamped case, it will be what? E power minus alpha t times a1 cos omega dt plus a2 sin omega dt. a1 cos omega dt plus a2 sin omega dt. So these are the forms of the natural responses in case of what? Overdamped, in case of critically damped, and in case of what? Underdamped. Okay. Once you write the natural response, you should add the steady state response or the forced response to the natural response to get the complete response. Then using the various initial conditions, you must find the values of the unknowns in the natural response, which are usually two unknowns in the form of what? A1 and A2. Now let's start looking at different second order circuits and try to find the response of each and every second order circuit to some input. Okay. So our first circuit, it is what? A parallel RLC network, RLC. Okay. Let VC be the voltage across the cap. Let IL be the current through the inductor. Look at the direction of current through the inductor. It is in the upward direction. And VC is what? The voltage across the capacitor. Polarity is what? Plus at the top, minus at the bottom. Okay. And the values of R, L and C are given. R is what? 6 ohms. L is what? 7 Henry. And C is what? 1 by 42 farad. C is what? 1 by 42 farad. R is 6 ohms. L is what? 7 Henry. And C is what? 1 by 42 farad. Okay, let me write this 42 properly. 1 by 42. And the two initial conditions are also given. What are the two initial conditions in this parallel RLC circuit? One is what? The initial current flowing through the inductor, meaning how much current flows through the inductor at t equal to 0. Another is what? The initial voltage across the cap, meaning what is the voltage across the cap at t equal to 0. Those two values are also given. IL of 0 is what? 10 amps, and VC of 0 is what? 0. Now the question is what? To find VC of t for t greater than 0. What is it? To find Vc of t for t greater than 0. Okay, number 1, it is what a parallel RLC circuit. So it is a second order circuit. Is it a second order circuit driven by any sources or not driven by any sources? Clearly in this RLC circuit there are no independent sources. So what do we have over here? It is a source free circuit. It is what a source free circuit, meaning no independent sources are driving this circuit. If any circuit is not driven by independent sources, and if the circuit reaches what? Steady state, then at steady state in a source free circuit, all voltages and currents will be 0. So can you tell me in this circuit what is Vc at steady state? It will be 0. In fact, not just Vc, each and every current in the circuit at steady state will also be 0. Why? Because it is not driven by any kind of source. Source free circuit at steady state, all voltages and currents will be equal to what? 0. So what is Vc at steady state? Because it is source free, directly we can say it is what? 0. So what is this 0 volts? It is nothing but the steady state response. It is nothing but steady state response. Steady state response, it means what? The value of the voltage or current at steady state. At steady state, the value of Vc is what? 0. So steady state response is also what? 0. But the total response will consist of what? 2 parts. Steady state response plus the natural response. Now you should also write the other part, which is what? The natural response. How do you write the natural response? Before you write the natural response of any second order circuit, first you should decide what is the nature of, or what is the form of the natural response. Will it be overdamped, or will it be critically damped, or will it be underdamped? How do you decide the form of the natural response? Is it not by finding the values of alpha and omega naught? So if you recall from last lecture, we know for a parallel RLC circuit, alpha is what? Given by 1 by 2 RC, and omega naught is what? Given by 1 by square root LC. So by using the given values of R, L and C, we must calculate the values of alpha and omega naught. Once you get the values of alpha and omega naught, you have to compare alpha and omega naught to decide the form of the natural response. If alpha is what? More than omega naught, then the natural response is what? Said to be overdamped. If alpha is equal to omega naught, then the natural response will be what? Critically damped. And if alpha is what? Less than omega naught, then the natural response is said to be underdamped. So anyway, let's find the values of alpha and omega naught. Look at this. 1 by 2 times R. What is R? 6 ohms. What is C? 1 by 42. 42 will go to the numerator. 42 by 2 is what? 21. 21 by 6 is what? 3.5. What are the units of alpha? Alpha is what? 1 by 2 RC. RC is what? Some type of time constant. It is not exactly a time constant in this case. So RC is what? Some time, okay? 1 by time is what? Per second. So what is the value of alpha? It is 3.5 per second. In the same way, let us also find the value of omega naught, which is 1 by root LC. 1 by square root of L into C. What is L? 7. What is C? 1 by 42. Again, 7 by 42 is what? 1 by 6. And this 1 by 6 is what? In the denominator, it will become what? Root 6. So omega naught is what? Root 6. Units. Omega naught is what? The resonance frequency. So it must be in the units of radians per second. So just look at the values of alpha and omega naught. Alpha is what? 3.5. Whereas omega naught is what? Root 6. Root 6 means what? 2 point something. Whereas alpha is what? 3 point something. Clearly, alpha, is it not more than omega naught? So from here, we can clearly see that alpha is what greater than omega naught. If alpha is what greater than omega naught, then the natural response is said to be OD. OD for overdamped. Yes, our natural response is what going to be overdamped. Now, what is that form of the overdamped natural response? Is it not the form A1 e power S1t plus A2 e power S2t? So, before you write the natural response, you should find the values of S1 and S2, which are what the two roots of the characteristic equation, which also happen to be the two poles of the circuit. Okay. So, what is alpha for us? 3.5. What is omega naught? Root 6. Now, what is this S1 comma 2? The two roots of the characteristic equation. You know they are given by minus alpha plus or minus square root of alpha square minus omega naught square. Just use the values of alpha and omega naught in this expression. So minus alpha is what? Minus 3.5 plus or minus square root of alpha square, which is what? 3.5 square minus omega naught square. Omega naught is what? Root 6. Omega naught square is what? 6. That's all. In this way, you will get the values of S1 comma 2 minus 3.5 plus or minus square root of 3.5 square minus 6. Okay. And the two values or the two roots are going to be what? Minus 1 comma minus 6. Minus 1 comma minus 6. Those are the two roots of the characteristic equation. Once you get the two roots of the characteristic equation, can't we find the natural response? What is the natural response? In case of overdamped, it is of the form A1 e power S1t plus A2 e power S2t. Now in place of S1 you write minus 1, in place of S2 you write minus 6. So won't you get A1 e power minus t plus A2 e power minus 60? Yes, this is the natural response. Okay. Already we know that the steady state response is what? 0, since it is a source free circuit. Now we should write the complete response, that is what? The complete expression for Vc of t. So always Vc of t will be equal to what? SSR, which is the steady state response, plus the natural response. In this case, the steady state response is what? 0, whereas the natural response is what? This A1 e power minus t plus A2 e power minus 60. So in place of NR, I should write A1 e power minus t plus A2 e power minus 60. That's all. So now we have what? Vc of t equal to A1 e power minus t plus A2 e power minus 60. So as you can see, in the complete expression for Vc of t, there are two unknowns, A1 and A2. So to solve for two unknowns, we obviously need two equations. How do you get those two equations? From the two given initial conditions. Okay. Let us go back and look at the two given initial conditions. What is the first initial condition? Initial current through inductor is what? 10 amps. Initial voltage across the cap is what? 0. I think this Vc of 0 equal to 0, it can be directly used because we have the expression for Vc of t. You substitute t equal to what? 0. When you do that, Vc of 0, substitute t equal to what? 0. If you put t equal to 0, e power minus t, e power minus 60, both will become what? 1, e power 0, e power 0. Now Vc of 0, will it not be A1 plus A2, and the given value of Vc of 0 is what? 0. So what is our first equation for A1 and A2? A1 plus A2 equal to what? 0. Let's call it our first equation. In the same way, we need to get one more equation to be able to solve for A1 and A2. Now the way to get it is what? Let's go back to the circuit. Okay, look at this. We just have the original circuit. Let's look at this circuit. Sorry. Let's look at this circuit at t equal to what? 0 plus. Let's look at the circuit at t equal to what? 0 plus. Let me call the current through the capacitor as what? IC. You know, at t equal to 0 plus, at t equal to 0 plus, what is the current through the inductor? What is the current through the inductor at t equal to 0 plus? Because the current through the inductor at t equal to 0 is what? 10 amps. Even the current through the inductor at 0 plus will also be 10 amperes because current through inductor cannot change suddenly or instantaneously. IL of 0 plus will also be, tell me, IL of 0 plus will also be 10 amps. Similarly, what is VC of 0 plus? It will be same as what? VC of 0, which is 0 volts. So right now we are looking at the circuit at t equal to what? 0 plus. We are looking at the circuit at t equal to what? 0 plus. So at t equal to 0 plus, because the voltage across the cap is what? 0. What is the drop across the resistor? It is also 0 because R, L and C are in parallel. Always they will have the same voltage drop. Drop across cap at 0 plus, if it is 0. Drop across R will also be 0. If the drop across R is 0, what is the current flowing through the resistor? Will it not be 0? What about the current through the inductor? IL of 0 plus is what? 10. So even now, the current through the inductor will be what? 10 amps. In what direction? In the upward direction. Now look at this 10 ampere current. Can it flow through R? No. Because the current through R is what? 0. The only way the current through the inductor can flow is through the capacitor. In fact, what is this current? Will it not be 10 amps? So is it not the value of IC? Because look at this 10 ampere and this IC, both are flowing in the same direction. So what is the value of IC at t equal to 0 plus? It is 10 amps. Okay. So IC at 0 plus is also what? 10 amps. Now what is the relation between IC and VC? IC is equal to what? C dVC by dt. From here, what is dVC by dt? Is it not IC by C? Now let's evaluate both the sides of this equation at t equal to what? 0 plus. That means dVC by dt at t equal to 0 plus will be equal to what? The value of IC at 0 plus divided by C. The value of IC at 0 plus divided by C. Already we know the value of IC of 0 plus is what? 10. So 10 divided by C. What is C? 1 by 42. So 10 upon 1 by 42. So is it not 420? So what is this 420? It is the value of dVC by dt at t equal to 0 plus. What are the units of dVC by dt? Volts per second. Because dVC means what? Change in voltage, volts. dt is what? The length of the interval, seconds, volts per second. So dVC by dt at t equal to 0 plus, it is what? 420 volts per second. I hope this is clear. 420 volts per second. Okay. Let us go back to our expression for Vc of t, which is a1 e power minus t plus a2 e power minus 6t. Let me write that expression here. Look at this. So what is our Vc of t? a1 e power minus t plus a2 e power minus 6t. Now let us differentiate both sides with respect to time. Left hand side will become what? dVc by dt. What is the derivative of the right hand side with respect to time? First term derivative will be what? Minus a1 e power minus t and then minus 6 a2 e power minus 6t. This is what the expression for dVc by dt. Now let's evaluate both the sides at t equal to what? 0 plus. Look at this. So dVc by dt at t equal to 0 plus. See, t equal to 0 plus means what? Just after t equal to 0. Just after t equal to 0, what is the value of the time instant? It is almost equal to what? 0. So even if it is what? T equal to 0 plus, the value of t will be what? Very close to 0. So on the right hand side, you just have to substitute t equal to what? 0. On the right hand side, if you substitute t equal to what? 0, won't you get minus, a1 minus 6 a2? But already we know dVc by dt at t equal to what? 0 plus. What is dVc by dt at t equal to 0 plus? It is 420. So left hand side, in place of this, you write 420. That's all. This is our second equation for a1 and a2. So always we get the second equation by finding what? The value of the first derivative of whatever current or voltage you are trying to find at what instant, at t equal to what? 0 plus. Always find the value of the first derivative. If you are finding voltage, dV by dt at t equal to 0 plus. If you are finding some current, di by dt at t equal to 0 plus. So from the value of the first derivative at t equal to what? 0 plus, you will get the second equation for a1 and a2. Already we have one more equation for a1 and a2. Now solving these two equations, you can get the values of a1 and a2. What was our earlier equation for a1 and a2? Directly from the given initial condition, we get a1 plus a2 equal to what? 0. So here also, let me write it. a1 plus a2 equal to what? 0. That's all. From these two equations, you should be able to solve for a1 and a2. If you add the two equations, minus a1 and a1 will get cancelled. Minus 6 a2 plus a2 is what? Minus 5 a2. So 420 by 5. I think a2 is what? Minus 84. If I am not wrong, a2, it must be minus 420 by 5, which is minus 84. If a2 is what? Minus 84. Remember, a1 plus a2 is what? 0. So a1 must be what? Plus 84. a1 must be plus 84. That's all. These are the values of a1 and a2. a1 is what? Plus 84. a2 is what? Minus 84. That's all. Now go back to this expression for Vc of t, which is a1 e power minus t plus a2 e power minus 60. In place of a1, you write plus 84. In place of a2, you write minus 84. I'll just do that. So Vc of t is what? a1 e power minus t plus a2 e power minus 60. And what did we get for a1 and a2? a1 is what? Plus 84, whereas a2 is what? Minus 84. So Vc of t will be what? 84 e power minus t minus 84 e power minus 60. Clearly 84 is what? Common. 84 times e power minus t minus e power minus 60. This is the complete expression for Vc of t. I hope the method is very clear. Okay. So always the complete response will consist of what? Two parts: steady state response plus the natural response. Since our circuit is not being driven by any kind of independent source, directly we can say at steady state any current or any voltage is going to be 0. So the steady state response is what? Going to be 0. Then to write down the natural response, we first have to decide the nature of the natural response, whether it is overdamped or critically damped or underdamped, for which we found the values of alpha and omega naught. So always remember, for a parallel RLC circuit, alpha is what? 1 by 2 RC, and omega naught is what? 1 by square root LC. Okay, by finding the values of alpha and omega naught and by comparing alpha and omega naught, we were able to decide that the natural response is what? Going to be over damped. And in case of over damped natural response, it will be of the form A1 e power S1t plus A2 e power S2t. And then using the initial conditions, we solve for A1 and A2. Now here, if you look at the expression for Vc of t, e power minus t, is it not a decaying exponential? E power minus 60, that is also what? A decaying exponential. Yes. Now between e power minus t and e power minus 60, which one will decay faster? Between e power minus t and e power minus 60, which one will decay rapidly or faster? Is it not e power minus 60? Yes or no? E power minus 60 will decay faster as compared to what? E power minus t. Okay. Now I'll just try to draw the waveform for Vc. I'll just try to draw the waveform for Vc. Look at this. So here's what Vc versus time. What is the first exponential? 84 e power minus t. What is the second exponential? 84 e power minus 60. What is the value of each exponential at t equal to 0? At t equal to 0, both exponentials are they not equal to 84? Yes. This is what? 84. I mean, if you put t equal to 0, it will become what? 84. Take the second exponential, that is 84 times e power minus 60. Again, if you put t equal to 0, it will become what? 84. So this is 84, this is also what? 84. That means both the exponentials will start from an initial value of what? 84, and they will exponentially decay to what? 0. But both are not going to decay at the same rate. One will decay faster, the other one will decay slower relatively. Okay. So here, let this be 84. Let this be 84. So between 84 e power minus t and 84 e power minus 60, this 84 e power minus 60 is what? The fast decaying exponential. 84 e power minus t is what? Slow. Okay. So this is fast. This is what? Slow. Fast decaying and slow decaying. Okay. So it's 84 e power minus 60. Sorry. It will do something like this. Whereas this 84 e power minus t, it will decay very slowly. I mean relatively slowly. So what is the first exponential? 84 e power minus 60. What is the second exponential which is decaying relatively slowly? It is 84 e power minus t. Now here our Vc is what? Not any of the two exponentials. It is the difference between the two exponentials. Okay. Difference between slow and fast. Difference between what? Slow and fast. Now at t equal to 0, both are equal to what? 0. Both are equal to 84, sorry. At t equal to 0, both exponentials are equal to what? 84. So the difference, will it not be 0? And as time increases, look at the difference. Is it not increasing? Yes or no? Difference is what? Increasing. And at some point, the difference will become what? Maximum. Thereafter, again the difference, you can see, it starts decreasing. So yellow color lines will indicate what? The difference between the slow decaying exponential and the fast decaying exponential. Initially the difference is what? 0. Then the difference is what? Increasing. It becomes what? Maximum. Again the difference is what? Decreasing. As time tends to what? Infinity. Both will decay to what? 0. Then the difference will be also equal to what? 0. 0 minus 0 is what? 0. As you can see, difference increases, becomes maximum. Again difference will decrease and become what? 0. So initially difference is what? 0. Then difference will increase, reach maximum. Again difference will start decreasing. It will ultimately become what? 0. So what is the waveform for Vc of t? So Vc versus t. At t equal to 0, difference is what? 0. So from 0 it will reach what? Maximum value. Then again it will decay to what? 0. That's all. I hope the logic is clear. So you can see VC, it starts from 0, it reaches what maximum value, and thereafter VC will decay to what? 0. You understood? Yes. So that's the kind of response we are going to get in our RC circuit. You understood? Yes. So once again, we have the same parallel RLC circuit. Let everything be same except for the value of resistance. So previously, what was the value of resistance? It was 7 Henry. Now let's make the resistance value as what? 10 root 6 by 2. I'll just write it. So what is the new? What is the new value of the resistance? Now it is what? 10 root 6 by 2 ohms. Just copy it. Everything else is what? Same. So now the value of resistance is what? Changed to 10 root 6 by 2 ohms. L is still 7 Henry and C is what? Still 1 by 42 farad. Even the two initial conditions will remain what? Unchanged. Even the two initial conditions will remain unchanged. Okay. Now also the question is what? To find Vc of t. Find Vc of t for t greater than 0. So very quickly, because it's a source-free circuit, the steady state response is what? 0. So without doing anything, we can directly say the steady state response is going to be 0 because this circuit is being not driven by any independent sources. So at steady state, all currents and voltages will be 0. So what is Vc of infinity? Vc of infinity is nothing but steady state response, and that is equal to what? 0. That is equal to what? 0. Now you should find the natural response, add it to this steady state response, which is 0. Okay. Now to find the natural response, obviously you should first compute the values of alpha and omega naught. What is alpha given by in a parallel RLC circuit? Alpha is what? 1 by 2 RC. So this time the value of R is what? 10 root 6 by 2. C is what? Same as before, 1 by 42. You know this 2 and this 2 will get cancelled. 42 by root 6. 2 and 2 will get cancelled. 42 by 10 is what? 4.2 by root 6. Anyway, is there anything wrong? Oh, sorry, there is a small correction. The value of R should be taken as 7 root 6 by 2. I think I wrote it as 10. It's not 10, it is 7. Okay, I'll just modify it. So the value of R, please change it to what? 7 root 6 by 2, not 10 root 6 by 2. So here also, instead of 10 root 6 by 2, I should write 7 root 6 by 2. Now what is the value of alpha? 2 and 2 will get cancelled. 42 goes to what? Numerator. 42 by 7 is what? 6. 6 by root 6 is also what? Root 6. So what is alpha? Root 6 units per second. Alpha is what? Root 6 per second. And again, omega naught, you know, is given by 1 by square root LC. 1 by square root LC. 1 by square root. You see the values of L and C have not been changed from the previous circuit. So even now the value of omega naught continues to be root 6. Anyway, let's find it. 1 by square root LC. L is what? 7. And C is what? 1 by 42. This is also, as I said, is going to be root 6 radians per second. Let me write it properly. Root 6 radians per second. Now look at the values of alpha and omega naught. Alpha is what? Root 6. Omega naught is also what? Root 6. So alpha root 6, omega naught root 6. Does it not mean alpha equal to omega naught? Whenever alpha is equal to what? Omega naught, then you know the natural response is said to be critically damped. So for alpha equal to omega naught, the natural response is what? Critically damped. CD for critically damped. And what is the form of the natural response when it is critically damped? It is of the form e power minus alpha t times a1t plus a2. Already alpha is what? Root 6. Okay. And remember, steady state response is what? 0. So now we are going to write the complete response. That is what? Vc of t is equal to what? Steady state response plus the natural response. Steady state response is what? 0. Natural response is what? E power minus alpha t times a1t plus a2. So it is what? I'll just write it as e power minus root 6t, because alpha is what? Root 6. E power minus root 6t times a1t plus a2. This is Vc of t expression. Again, there are two unknowns, a1 and a2, which should be found in the same way as we found for the previous circuit. One is what? Directly substituting t equal to what? 0. If you substitute t equal to 0, left hand side becomes what? Vc of 0. Right hand side, if you put t equal to 0, a1 into 0 is what? 0. E power 0 is what? 1. So 1 into 0 plus a2 is what? Just a2. But what is the given initial voltage across the cap? It is given that Vc of 0 is what? 0. Vc of 0, 0, it means what? A2 is going to be 0. If A2 is what? 0, then Vc of t can be written as what? E power minus root 6t times a1t, because a2 is what? 0. I'll omit a2. So Vc of t will be what? E power minus root 6t times a1t. Now the only unknown left is what? a1. You should do something to find what? a1. Last time what did we do to get the second equation? Did we not find the first derivative value at t equal to what? 0 plus. So now also let's differentiate this with respect to time, dvc by dt. What is the derivative of this with respect to time? Would it not be minus root 6 and then a1 and then e power minus root 6t and then there is what? T plus a1 e power minus root 6t. Yes, this is the derivative of the right hand side. Minus root 6 a1 e power minus root 6t times t plus e power minus root 6t times a1. Now we have to evaluate this at t equal to what? 0 plus. So evaluating anything at t equal to 0 plus is same as what? Substituting t equal to 0. So if you substitute t equal to 0 on the right hand side, e power 0 is what? 1, but then we have also what? T. If t is 0, 0 multiplied by anything becomes what? 0. But the second term, e power 0 is what? 1. So is it not just a1? It is what? a1. Now from the given initial conditions, you should find the dvc by dt value at t equal to 0 plus, so that we will directly get the value of a1, because dvc by dt at t equal to 0 plus is same as what? a1. And for that we should draw the circuit at t equal to what? 0 plus. So once again we have the original circuit. Let us visualize this circuit at t equal to 0 plus. Everything is same as before. At t equal to 0 plus. And by the way, the value of R, now it is what? 7 root 6 by 2. 7 root 6 by 2 ohms. But that does not make any difference for the value of dvc by dt at t equal to 0 plus, because anyway at t equal to 0 plus the voltage across the cap will be what? 0, because Vc of 0 is what? 0. Now the drop across R will also be 0. So the current through R will be what? 0. What is the current through the inductor at t equal to 0 plus? Same as IL of 0, which is 10 amps. Once again, let this current be what? IC. So what is IC of 0 plus, will it not be 10 amps? Yes or no? IC of 0 plus will be equal to what? 10 amps. IC of 0 plus is what? 10 amps. But you know, IC of 0 plus, if it is what? 10 amps. 1 second. dVc by dt at t equal to 0 plus. dVc by dt at t equal to 0 plus, we know it is simply equal to what? IC of 0 plus, current through the capacitor at 0 plus divided by C. IC of 0 plus divided by C. What is IC of 0 plus? It is 10 amps, because the current through inductor is what? 10 amps, and the current through resistor is what? 0. This entire 10 ampere will flow through what? The capacitor. So current through the capacitor at 0 plus will also be what? 10 amperes. So IC of 0 plus divided by C. C is what? 1 by 42. Is it not 10 divided by 1 by 42? 10 divided by 1 by 42 is what? 420. So dVc by dt is what? 420 units volts per second. That's all. So dVc by dt at t equal to 0 plus is what? A1. So now we obtain the value of A1 as what? 420. Of course, volts per second. A1, it must be 420 volts per second. Okay. So let us go back to this expression for Vc of t, which is e power minus root 6t times A1t. So in place of A1, you write 420. So will it not become 420t times e power minus root 6t? I'll just write it on the next slide. So Vc of t is what? E power minus root 6t times A1t, where the value of A1 has been found to be 420. So now what is Vc of t? Will it not be 420t times e power minus root 6t? 420t times e power minus root 6t. That's all. This is the final expression for Vc of t. If you want, you can verify both the extreme conditions or extreme values of Vc. You know, at t equal to 0, Vc must be 0. If you substitute t equal to 0, t is what? 0. Then 0 into anything will also be what? 0. So Vc of 0, even from this expression, it is going to be what? 0. If you substitute t equal to infinity, at t equal to infinity, okay, this t will tend to what? Infinity, but e power minus root 6t will become what? 0. And this is a stronger function compared to what? T. Yes or no? So if you take the limit of this expression as t tends to what? Infinity, that limit is going to be what? 0. I mean, e power minus root 6t is same as what? 1 by e power root 6t. And then you know how to write the series for the exponential. What is e power x? 1 plus, you know, x plus x square by 2 factorial plus x cube by 3 factorial and so on. In that way, if you try to expand this exponential, and then if you substitute t equal to what? Infinity, you will find that denominator is what? Like infinity plus infinity square plus infinity cube plus infinity power 4 and so on. Whereas numerator will be what? Just infinity. So infinity, this infinity will get cancelled, but in the denominator, you know, infinity, infinity square, infinity cube, they will remain. So in the denominator, if you have what? Infinity, infinity square, infinity cube, denominator will be what? Infinity. Anything by infinity is what? 0. So the point is what? If you substitute t equal to infinity, Vc will turn out to be 0. And our circuit is also what? A source-free circuit. So at t equal to 0, at t equal to infinity, Vc must be 0. Okay. Now let us just plot Vc versus t. You see, if you look at this, Vc versus t, or if you look at the expression for Vc of t, does it not consist of two functions? One is what? 420t. The other function is what? E power minus root 6t. 420t, is it not going to increase with time? 420t will increase with time. E power minus root 6t, it will decrease with time. So we are multiplying two functions where one function is going to increase with time linearly, whereas the other function will exponentially decay with time. So when you multiply these two functions, what is resulting function, or how does this product vary with time? You see, initially when t is what, very small, for very small values of time, 420t will be a dominant function as compared to what, e power minus root 6t. That is for very small values of t. If 420t is what, the dominant function, and there is what, the secondary function which will get dominated by this first function, overall Vc will increase with time, because 420t will be what, the dominant function for small values of t, and 420t will increase with time. In other words, the rate of increase will be greater than the rate of decrease. That means what, the net rate of change will be what, an increase. So initially Vc will increase with time, but as time increases, at some point the exponential function will take over, and that will become what, the dominant function. Once this becomes dominant as compared to what, 420t, because the exponential function is going to decay with time, the net rate of change will be what, negative, or the function will start decaying with time. Initially this is dominant, Vc will increase, then after some time this will become dominant, then Vc will start decreasing. So first increasing, then decreasing. So will it not reach a maximum value in between? Yes. So Vc increases, reaches what, a maximum value, and then it starts decreasing. So I mean, in terms of the shape of the response, is it not same as the overdamped case, even in case of overdamped previous circuit, where the value of R was what was the value of R? I think R is what, 6 ohms. In the previous circuit, R is what, 6 ohms. Now the value of R is what, 7 root 6 by 2 ohms. The response is what, same. Initially it starts from 0, it increases, reaches what, maximum value, then again exponentially it will decay to what, 0. Okay, that's all. There is the kind of response we get when the system is what, critically damped. So the shape is what, same as overdamped. The shape is what, same as overdamped. Okay, let's take up one more example. So again we have the same parallel RLC circuit. Let us again modify the value of resistance, keeping everything else the same. Okay, that means values of L and C will remain unchanged. Even the two initial conditions are not going to change, but we will change the value of R. So now the new value of R is what, 10.5 ohms. Just note it. Circuit is what, same, parallel RLC circuit, not driven by any independent source, but the value of R is now equal to what, 10.5 ohms. Okay, so very quickly, again the goal is what, to find Vc of t for t greater than 0. Even in the previous two circuits we found the same thing, Vc of t for t greater than 0, overdamped and critically damped. Now again let's find Vc of t for t greater than 0. See, because it's a source-free circuit, the steady state response is what, 0. That means Vc of infinity is also what, 0. Now what, you should find the values of alpha and omega naught. Again for a parallel RLC circuit, alpha is what, 1 by 2 RC. So 1 by 2 times R is what, 10.5, and C is what, 1 by 42. 2 into 10.5 is what, 21. 21 by 42 is what, half. 1 by half is what, 2. So this time the value of alpha is what, 2 per second. Omega naught will be given by 1 by square root LC, because the values of L and C are not being changed. Omega naught continues to be, root 6 radians per second. So now look at the values of alpha and omega naught. Alpha is what, 2. Alpha is what, 2, whereas omega naught is what, root 6. What is root 6? Is it not 2 point something, which is more than 2? So omega naught is what, 2 point something. Alpha is what, 2. So clearly this time alpha is what, less than omega naught, whenever alpha is what? Less than omega naught, the natural response is not going to be oscillatory or underdamped. Yes, in case of underdamped natural response, you are going to have oscillations, but the amplitude of oscillations will decay with time. So NR is going to be UD for underdamped. Whenever the natural response is what? Underdamped, you should find the value of what? Omega D, which is the natural resonant frequency, and the natural resonant frequency is the frequency at which the natural response will oscillate. Okay, and if you recall that omega D, which is what? The natural response, will be equal to square root of omega naught square minus alpha square. What is omega naught? Root 6. Omega naught square is what? 6. Alpha is what? 2. Alpha square is what? 4. So square root of 6 minus 4, is it not root 2 radians per second? That's all. That is the value of omega D. Once you get the value of omega D, we can write the form of the natural response. You know, for underdamped natural response, the natural response will be the form e power minus alpha t times a1 cos omega dt plus a2 sin omega dt. We have the value of alpha, we also have the value of omega d. So in place of alpha, you write 2, it becomes what? E power minus 2t times a1 cos omega d is what? Root 2, a1 cos root 2t plus a2 sin root 2t. Once again, as you can see, we have two unknowns, a1 and a2. So to this natural response, you add steady state response. Anyway, in this case, the steady state response is what? 0. We will get the complete response or the full expression for Vc of t. So now Vc of t will be equal to what? SSR plus NR. So what is this SSR? 0. NR is what? E power minus 2t times a1 cos what is omega d? Omega d is what? Root 2. Omega d is what? Root 2. So a1 cos root 2t plus a2 sin root 2t. This is the expression for Vc of t. Now to solve for a1 and a2, you should make use of the two given initial conditions. First is what? Very straightforward. You simply substitute t equal to what? 0. If you substitute t equal to 0, Vc of 0, if you substitute t equal to 0, cos 0 is what? 1, sin 0 is what? 0. So a2 into sin 0 will also become 0. E power minus 2t at t equal to 0, e power 0 is what? 1, cos 0 is what? 1, 1 into a1 into 1, is it not just a1? But you know the given initial voltage across the cap is what? 0. So what is Vc of 0? It is 0. So a1 is also going to be 0. Once you know that a1 is what? 0. Now what is the expression for Vc of t? This entire term will become what? 0, because a1 is what? 0. 0 into cosine function will also be what? 0. Now only this part will remain, and this will get multiplied with e power minus 2t. So will it not be a2 e power minus 2t times sine root 2t? Let us again differentiate this with respect to time. Left hand side will be what? dVc by dt. What is the derivative of the right hand side with respect to time? Tell me, what is the derivative of the right hand side with respect to time? If you differentiate this with respect to time, I mean, you first have to differentiate the exponential, then you should differentiate the sine function. Let's differentiate the exponential first. Will it not be minus 2a2 e power minus 2t sine root 2t minus 2a2 e power minus 2t sine root 2t? That is what? Derivative of the exponential. Now you should differentiate the sine function. If you differentiate the sine function, I think you will get a2 root 2 e power minus 2t. Differentiation of sine is what? Cos root 2t. Cos root 2t. And then, we should evaluate the derivative at t equal to what? 0 plus. If you are evaluating anything at t equal to 0 plus, I told you what? You should substitute t equal to 0. So right hand side everywhere in place of t you put 0. What is sine 0? It will be 0. That means this entire first term will become what? 0. And second term e power 0 is what? 1. Cos 0 is also what? 1. So this a2 times root 2 will remain, and this of course is what? 1. So what is dvc by dt at t equal to 0 plus? It is what? a2 root 2. It is what? a2 root 2. Now we should draw the circuit at t equal to 0 plus and get the actual value of dvc by dt at t equal to 0 plus. Look at this. Again, it is same as what we have done for the previous two cases. So now, first of all, R is how much? It is 10.5 ohms. Right now we are looking at the circuit at t equal to what? 0 plus. At t equal to 0 plus, what is the drop across the cap? 0. So what is the drop across R? 0. What is the current through R? 0. What's the current through the inductor? Same as IL of 0, which is 10. Let IC be the current through the capacitor. Because this 10 ampere cannot flow through resistor, it will entirely flow through what? Capacitor. So what is IC of 0 plus? It is again 10 amps. If IC of 0 plus is what? 10 amps. dvc by dt at t equal to 0 plus will always be IC of 0 plus divided by C. IC of 0 plus is what? 10. C is what? 1 by 42. So is it not 420 volts per second? So dvc by dt at t equal to 0 plus will be what? 420 volts per second. Okay. Previously, we found that dvc by dt at 0 plus is what? a2 root 2. That means what? This a2 root 2 should be equal to what? 420. I'll do it here. So left hand side, I'll write a2 times root 2. Now this root 2 will go to the other side. So that a2 will become what? 210 root 2. a2 will become what? 210 root 2. What is our Vc of t expression? This a2 e power minus 2t and then sine root 2t. Now we have the value of a2 as what? 210 root 2. So now Vc of t is what? 210 root 2 e power minus 2t. E power minus 2t sine root 2t. E power minus 2t sine root 2t. That's all. Okay. Just look at this. There is a final expression for Vc of t. 210 root 2 e power minus 2t and then sine root 2t. Again, it is what? A product of two functions. One is what? The sine function. Sine root 2t. Will it not sinusoidally oscillate at a frequency of what? Root 2 radians per second. Well, this function is getting multiplied with another function. Look at the other function. 210 root 2 e power minus 2t. Is it not a decaying exponential function? Yes. Now for the sine function, this 210 root 2 e power minus 2t, is it not like the amplitude of the sine function? But the amplitude, is it constant or decaying with time? Amplitude contains what? E power minus 2t, which will decay with time. That's why the amplitude of oscillation will exponentially decay with time. Okay. so that after a long time e power minus 2t will decay at what 0, amplitude becomes what 0, there will be no more oscillation in the circuit. Yes. So when is the amplitude maximum? Max amplitude, what is the max amplitude? At t equal to 0, amplitude of oscillation will be maximum. If you put t equal to 0, will it not be 210 root 2? Yes. So once again, if you try to draw the waveform for Vc, that is what plot Vc versus t. At t equal to 0, Vc is what 0. I mean Vc of 0 is what 0. And then it will be a sine function but with an amplitude which will exponentially decay. So initially amplitude is what maximum. As time progresses, amplitude will exponentially decay. So should it not be something like this? So as you can see, the amplitude, it is exponentially decaying. You understood? Yes. So after a long time, the amplitude will become what 0. Even Vc will become what 0. Because at steady state, because there are no independent sources, Vc should become 0. Amplitude decays to what 0. Vc also will become what 0. That's all. These are the three cases. First is what over damped. Second is what critically damped. Third is what under damped. I hope the approach is clear. So once you have understood this approach, the same approach can be used to find the response of any second order circuit. And the two types of second order circuits that we encounter are what? The parallel RLC circuit and the series RLC circuit. Okay. So far we have been looking only at the parallel RLC circuit. We also have the series RLC circuit. Anyway, it is about 8:30. So I think we'll meet in the next session.